Hi, and welcome to my walkthrough of AS315 Lab 7. In this lab, we use a piezo, 4 switches, and 4 resistors. The switches are set up in a parallel circuit, and when closed, brings in the associated resistor into the parallel circuit. And the output of the parallel circuit provides the input for the Arduino's analog input at pin alpha 0. This setup is known as a resistor ladder. The first switch, one side on its input, is receiving power from the 5 volts bus line. The other output of the switch is going to the output of the second switch, and that output is going to the third switch output, and that to the fourth switch output, which brings them into the parallel circuit when closed. The first resistor is a 220 ohm resistor going to the second switch's input and to the 5 volts bus line. The second resistor is a 10k ohm resistor coming from power to the third switch's input. The third resistor is a 1 mega ohm resistor coming from power going to the fourth switch's input. At the fourth switch, the output goes to another 10k ohm resistor and is in series with the analog input alpha 0. This fourth resistor is not a part of the parallel circuit. It comes after the parallel circuit and is in series with the parallel circuit, which goes to ground and to the Arduino's input. From the digital output from the Arduino board, we have the input to the piezo, and on the other side of the piezo, we have going to ground. Now, the way these switches work, when they are closed, each output is tied to a specific built array variable within the Arduino's code. So switch 1 has its own determined or specific noise or tone. Switch 2 has its own, as well as 3 and 4. As we press the switches, we will hear these tones. But when we press more than one switch at a time, the tones do not combine. The tone heard from the piezo will be the tone of the lowest resistor, or the switch associated with the lowest resistor. Now, this isn't because the lower resistor is the only path that the current will go through, but because when 2 switches or more are put into a parallel circuit, the way it turns out with these specific resistors is that the equivalent resistance is going to be fairly close to the equivalent resistance of the previous. For example, if we press the second switch, the path is only going through the 220 ohm resistor prior to reaching the 10k ohm and the current going to the Arduino. But if we press switch 2 and switch 3 at the same time, we bring the 220 ohm resistor and the 10k ohm resistor into a parallel circuit. Now, using the parallel resistor equation, you can determine that 220 ohms and a 10k ohm resistor in parallel will bring an equivalent to about 215 ohms, which is pretty close to 220 ohms of just the one. Now, the way that the code is written, because 215 ohms is close to 220 ohms, which is associated to switch 2, the Arduino, the code, the software is seeing this 215 ohms as it's within the threshold for the current output of just the 220 ohms. The Arduino sees that output as switch 2. And the same goes as if you were to hold down switch 2, 3, and 4, combining the 220 ohm resistor, the 10k ohm resistor, and the 1 mega ohm resistor into a parallel series. The equivalent resistance of the 3 is still going to be 215. So in this example, if we hold down all 3, we will only hear the tone associated to switch 2. Not because current's only going over switch 2, but because the current is going through these 3 switches, just with an equivalent resistance equal to a similar value of just the 220. And the same applies for the other switches. So when we press these switches or hold them down, if we start with the 4th and hold it down, we will hear the tone. But now if we hold down both, we will hear the previous or the lower associated resistance, because when we bring in these values of the resistors into the parallel, we will find that because of their resistant values, it's going to be around the equivalency of the lower resistor. And this is just based specifically just because these are the correct resistors to have in order for them to equal an approximate number. So you can hear the tones associated to each. So stepping down, we are allowed, it allows us, but stepping up doesn't work. This is all because of the parallel series or parallel circuit equation for the resistors I just explained. And that sums up all of Lab 7. Thank you.